In section B, if you find a triangular paper and then they give you some link about some triangles, 99.9% you are going to use these two formula, the sine formula and also the cosine formula, to describe the relation between sides and also angles. Beware that this is sine A. It's not just A here. It's not just angle A. Anyway, our target is angle BAM. BAM. So this is our target. Maybe we let it be theta. But don't forget to answer the question directly about angle BAM. So now this angle is involved in two triangles. We have the smaller one ABM, or we have the larger one ABC here. If we copy down the first triangle AMB, we have 25 degrees, we have our target theta, we have 14. That's all we can find out. It seems like it's not enough, so we look at another triangle. This time we look at the bigger one, ABC. So triangle ABC, we know the total length is 50, we know 48, we know 14, and together with one angle, which is our target. So it's obvious the second, the red triangle, give us more information. That's why we choose this one. It's very important for you to draw it separately and don't put everything in our mind. In our mind, basically, we have to separate it also. So why don't just simply copy down on a paper? That's why we invent paper. And then we are going to choose which formula we are going to use. We are going to describe the relation between one angle and three sides here. So obviously, we can't use sine formula because we have only one angle, including our target. We should use the cosine formula, which describes 1, 2, 3 sides and also one angle. We start our calculation now. So first of all, we are going to write down cosine formula. Something square is equal to something square plus something square minus 2 something something cosine something. And the only angle here we have is theta, so we are going to write theta inside the cosine function. Afterward, the corresponding sides, which is referred to C, so you see angle C and the length C here. This must be 48, so 48 is alone. And then another two sides we replace here, which is 50 and 14. So 50, 14, 50, 14. We build up equation and then with only unknown, which is theta, so we can solve this equation. I want to have theta term alone in left hand side, so I just move the term, or both sides plus 2 times 50 times 14 cosine angle C. And then we have 50 square plus 14 square here. I don't want this term stay in left hand side, so I move it to another side, both sides minus 48 square. That's why sometimes we write down the formula in another format. It's 50 square plus 14 square minus 48 square divided by 2 and 50 and 14. We divide both sides by this factor, so that's why only cosine is left. And then we are going to use calculator to get the ratio. We get 392 over 1400. Because it's not final answer, not necessary for you to simplify it, but we need theta, so both sides do opposite of cosine, add cosine. We use the corresponding length ratio to trace back what is the suitable angle to fulfill this requirement. Then we get this answer, and please write down as much as digit you can and also store it into calculator. Most probably we are going to use it in the following parts. And don't forget, don't just leave in theta. Theta is just because we get used to this symbol. We are talking about angle BAM here. If you don't write this one down, then no one knows that what is theta here. We didn't define it. And then in the following part, we are going to find out AM. It's come from the smaller green triangle. So we call back this triangle. Our target is to get AM here. While we already know this angle, before that it's not known, but now we know that it's 73 point something. So again, we are going to see whether we can use this kind of formula. Including our target, we have one side, two sides, one angle, two angles. So we are going to use the sine formula. But there are some restrictions. If you choose AM, then you need to find out this angle ABM, but it's not difficult. We just use 180, subtract the rest, then we get this angle. And then 14 to the opposite angle, sine 25 degrees. So we can build up an equation with AM only. Therefore, the first step, we are going to write down angle ABM first. It's just equal to 180 degree minus 25 degree, and also minus angle BAM. We get 81.2602047.1 and then we are going to use the sine formula now. We already have this angle 80 something, so AM to this side, this angle should equal to another pair 14 to sine 25 degree. We want AM, we don't want divided by this, so that's why it is AM equal to 14 over sine 25 degree times sine 81.2602047.1 degree. So AM is 32.74 something. We finished first two parts. We are going to work on part B. We fold it along BM, so M is no longer on the ground but is above the ground. We fold it and then until A and C the distance is exactly equal to 47. We are going to find angle AMC, A to M to C. Originally it is a straight line, straight angle 180, but if we fold it and then make M leave the ground, so we have an angle AMC here which should be less than 180. So we are finding this angle. Whenever you need to find an angle, beware that we are not good in handling 3D, so we should transform it to 2D diagram first. The triangle with this angle is just triangle AMC here. So I'm going to draw this triangle along and then I'll look at the top view. If we look at the top view, consider triangle AMC. We have our target, angle AMC. We have point M, point C. We know that AC is 47. And don't forget that what we have done in part A, somehow it is related. We already find A to M, so this one is 32 point something. And about MC, so from A to C in total is 50. We know A to M is 32 point something. So the rest MC, we can also use 50 subtract this section. We get 17.2578269. Similar reason. One side, two side, three sides together with one angle. We are going to use the cosine formula here. We write down something square is equal to something square plus something square minus 2 something something cosine something. And cosine that angle is angle AMC, our final target. We are going to input these three links. Opposite sides 47 must be placed along here. By using calculator and solving equation, we know that cosine angle AMC is equal to negative 0.74250465 something. Therefore, we get angle AMC. In part B, we have to let a point N lying on AB somewhere here, such that MN is perpendicular to AB. So that means there is a point N here to make this become perpendicular, such that MN are perpendicular to AB. So we can use this blue line to represent the plane AMB here. Afterward, there is a person called Andy claimed that the angle between the face ABM, that means this plane, and the horizontal ground ABC, the angle is angle CNM. Do you agree that the angle between CN and NM can become the angle of two planes? So just now I say that whenever we talk about angle between planes, we need to find some representative line. That means a blue line which is perpendicular to the intercept line. This can represent the plane here. So, but how about the horizontal ground? We have to draw one line to represent the plane. So the roots are from one vertex. We are going to draw a point perpendicular to the intercept line here. So we have to draw a line from C to AB, which is perpendicular. Now the problem is that go to N or some other position here? If CN is perpendicular to AB, then okay, that's fine, the claim is correct. But in other words, if C to perpendicular line AB, maybe we let this one be M. If CM and AB perpendicular, but N and M are not the one single point, then we have to reject the statement. If N and M do not meet at the same point, then maybe from N we draw a perpendicular line will finally go to one position here, but not C. So the angle between the planes is talking about this angle. But anyway, how do we prove that N and M are the same point or different position here? For the blue plane, we can get the position, the length of AN. For the red plane, we can get the position of A to M here. And then we see compare this length, are they the same or not the same? Then we know that whether they join at the same point. But before we start, most probably they do not join at the same point. It's because triangle AMB are not isosceles. So if you look directly straightforward to triangle AMB, it's not left and right symmetric. We already make the decision what we have to do. So the first part is just consider the blue plane here. Triangle ABM. N is somewhere here. We are going to find out the length of AN is our first mission. And look at this graph. So M to N is talking about this one. Beware that we already have theta. So we can just simply use AM, the length, and then cosine theta. We will get this section. So AN is equal to AM and then cosine angle MAB. We have these results and then we just use the calculator. We finish half of the question. We get 9.167808443 something. And then we are going to work on another red plane here. The horizontal ground ABC from the top view. So we are going to see whether this AM are the same as AN. What we know is on this plane, AC is a fixed distance to 47, AB is 14, and then BC is equal to 48 here. There are two methods to get AM here. The first method is we use cosine formula. We can get this angle CAB. Afterward, we can use the cosine ratio again. This hypotenuse times cosine of this angle, then we will get our target. Then we can compare with AN. Some other methods, like you can use the hero formula to get the whole area, and then we divide it times 2 divided by the base, we get the height. Then we can use Pythagoras theorem, 47 square minus the height square, and then we take square root, we also get the answer. I prefer the cosine formula. So this is our target. For example, this is confined. Then we have 48 square is equal to 47 square plus 14 square minus 2. 47, 14 cosine phi. Then we solve cosine phi is equal to 47 square plus 14 square minus 48 square. Divide by 2, divide by 47, divide by 14. Then we take shift cosine, we get the angle is 85.5983519. After that, we can just use AM, the same method as AN. Therefore, AM is equal to AC times cosine phi here. So AM is 3.607142857. And it's definitely not equal to AN. So they do not cross at the same point. That's why we say that the claim is wrong.